beautifully rigid pipeline. But there is a massive piece of underlying technology that makes all of this possible, specifically for the QA testing process. The sources refer to it as the persistent headless chromium daemon.
Ah, yes.
And I think this is honestly the most brilliant technical implementation in the entire stack.
Let's really break down why giving an AI a web browser is traditionally an absolute nightmare.
Well, the primary enemy of all developer productivity is latency, right? Just waiting for the machine to do something.
Yeah.
If you ask an AI to visually test a web application, the standard protocol for the last few years is for the AI to launch a brand new instance of a web browser from scratch.
In computing terms, they call this a cold start.
Exactly.
A cold start.
It's like a chef deciding to cook a meal, but first they have to drive to the grocery store, buy all the raw ingredients, drive back, and unpack everything before they can even think about chopping an onion.
That's a perfect analogy. A cold start for a browser can take 3 to 5 seconds. Now, imagine the AI is trying to test a button on your site. It tests it, realizes it's broken, tweaks the code, tests it again, tweaks it again.
If it has to suffer a 5-second cold start every single time it wants to look at the page,
the latency compounds massively. It becomes unbearably slow. You're sitting there for minutes watching it spin.
Yeah.
Furthermore, because it's a fresh browser every single time, it has absolutely no memory.
Oh, right.
It doesn't remember that you logged into the application 2 minutes ago. It loses all your session tokens.
So what did Gary Tan do differently with Gstack to solve this?
He just eliminated the cold start entirely. Gstack runs a headless Chromium browser, which just means a regular Chrome browser without the graphical user interface taking up screen space.
It's invisible.
It's invisible, and it runs it continuously in the background as a background process, or a daemon. It communicates with this browser over a local network connection using localhost HTTP.
So to go back to the chef analogy, the ingredients are just sitting on the cutting board permanently.
Right.
The mise en place is ready to go the second you need it.
Exactly. Because the browser never closes, the latency drops from 5 seconds down to roughly 100 to 200 milliseconds.
That is essentially instant.
It is. But the speed is really only half the magic. The real power is state persistence. The browser remembers everything. The cookies, the open tabs, the local storage, your active login sessions, they all persist across different AI commands for up to 30 minutes of idle time.
Wait, so this changes everything for the queue and browse commands, right?
Yeah.
The AI can log into your application as a test user, click around, notice a styling bug, jump back into your code, fix the CSS, and then instantly refresh that existing browser tab to verify the fix worked without having to re-authenticate or log back in.
Yes, and it does this with surgical precision because Gstack ties the QA process directly to the branch diffs.
Explain this for the audience.
A diff is just the documented difference between the old code base and the new code you just wrote. Let's say you built a massive application, hundreds of pages, but today you only changed 8 specific files that alter the checkout page.
The AI isn't going to waste its time testing the user profile settings or the homepage, right?
Right.
Because nothing changed there.
Exactly. It looks at the diff, understands that only the checkout flow was modified, and specifically directs the persistent browser to navigate to the checkout URL and test only those newly affected user flows. It's context-aware, automated testing happening in real time.
That is incredibly smart. Now, to make this persistent browser system work so smoothly, Tan made a very deliberate architectural choice that has a lot of developers talking.
That runtime choice.
Right. He didn't build Gstack using Node.js, which has been the default JavaScript runtime environment for basically over a decade at this point.
Yeah.
He built it using a much newer runtime called Bun. Why did he do that?
Node.js is incredibly powerful, obviously, but it has decades of legacy baggage attached to it. Bun, on the other hand, was designed from the ground up relatively recently for raw speed and modern developer ergonomics. The Gstack architecture notes explicitly cite 4 main reasons for choosing Bun over Node.
What's the first one?
First, compiled binaries. Bun allows you to package the entire Gstack toolkit into a single, standalone executable file.
Oh, so you don't force the user to download a massive folder of dependencies and manage package versions.
Exactly. They just run one single file and it works.
Which is huge for adoption, taking that friction away. What else?
Second is native TypeScript execution. Most modern JavaScript is actually written in TypeScript these days, which adds helpful safety checks. But Node.js usually requires you to run a separate tool to compile your TypeScript down to regular JavaScript before it can run it.
It's an extra step.
Right. Bun executes TypeScript natively out of the box, saving a massive step and reducing complexity. Third is bun.serve, which is this incredibly fast, lightweight, built-in HTTP server that manages the communication with that persistent browser daemon perfectly.
Okay, so those are all really solid efficiency gains.
Yeah.
But there is a fourth reason, and when I read this in the source material, I actually laughed out loud because it is such a delightfully clever hack.
The SQLite access.
Yes, native SQLite access. Break this down because it's brilliant.
It really is. So your primary web browser on your computer, let's say Google Chrome stores, all of your active login cookies inside a local SQLite database file hidden deep in your hard drive.
That's how it remembers you're logged into Twitter or whatever.
Right. Normally, if a developer wants a script to read a SQLite database, they have to install these clunky third-party C++ packages. It's a total headache.
But Bun has native SQLite reading built right into its core.
Exactly. Because of this, Gstack features a command called setup browser cookies. When you run this command, Gstack silently reaches into your personal Chrome browser's database on your computer, extracts your active login sessions for whatever development site you're working on, and smoothly injects them into the AI's headless browser.
That is wild. You just hand the AI your own human login state, completely bypassing the need to teach the AI how to navigate a complex login screen with, like, two-factor authentication and CAPTCHAs. You just say, here are my keys, go test the app.
It's optimizing for human convenience over technical purity. It's a total shortcut, but it works perfectly.
And that level of polish, that focus on removing friction, is exactly why the launch was so explosive. But as we know, an explosive launch always generates shrapnel. Let's look at the launch at SXSW and the massive fallout that followed.
So Gary Tan was on stage with legendary investor Bill Gurley when they started really talking up this idea of cyberpsychosis. And it's important to note, it wasn't a dry technical presentation. He was pitching an emotion.
He was selling a feeling.
He was selling the promise that a single developer sitting in their bedroom could wield the output of an entire funded startup team.
That is an intoxicating narrative, especially for an industry that has been battered by layoffs over the last few years. People want to feel empowered.
And the metrics prove how desperately developers wanted to believe it. We talked about the 50,000 stars on GitHub, but there is a secondary metric that tells a much deeper story: the star-to-fork ratio.
Explain the difference between those two for the listeners.
On GitHub, a star is essentially a bookmark or a like. It's passive. You see something cool, you star it. A fork, however, is active. It means a developer physically copied the entire repository to their own account so they could dissect the code, modify it, and actually use it in their own projects.
So what's a normal ratio for a successful open source project?
A very healthy, successful project might see 4 or 5 stars for every one fork. Gstack's ratio spiked to between 8 and 15 times the normal baseline. Developers weren't just passively liking this thing. An unprecedented percentage of them were tearing it open to see how the engine worked. They wanted to use it immediately.
And the absolute gasoline on that viral fire was the God mode anecdote.
Yes. This was the tweet that essentially broke tech Twitter for a week.
What happened?
Gary Tan shared a direct message from a CTO friend of his who had integrated Gstack. This CTO claimed that he unleashed the Gstack review agent on his company's proprietary codebase. The AI methodically scanned the code and discovered a deeply buried critical XSS vulnerability, the kind we talked about earlier,
Right.
a vulnerability that his entire team of human senior engineers had completely missed. The CTO dubbed the tool God mode and essentially prophesied that it would become legally mandatory for every code base in the world to use it.
See, I read that story, and my immediate reaction wasn't awe. I thought, wait a minute. If an AI prompt finds a glaring security hole that an entire department of highly paid senior engineers missed, my first thought isn't, this AI is God. My first thought is, what is structurally wrong with this company's hiring and code review process?
And that reaction is exactly where the massive backlash started. The tech community fractured into camps. The outrage over the God mode story was intense. Let's call this the professional recklessness critique.
That's a good name for it.
Veteran security engineers argued that praising the AI was masking the real issue: horrific engineering hygiene. If a generic workflow wrapper caught a critical XSS flaw, it meant your automated testing, your peer reviews, and your fundamental security protocols were fundamentally failing.
It's like a restaurant praising a new brand of bleach for finding mold in their kitchen, while ignoring the fact that they haven't mopped the floors in a year. The bleach isn't a miracle. Your kitchen is just disgusting.
A perfect analogy. Promoting Gstack as a miracle cure for bad engineering was seen as highly irresponsible by the old guard.
But the criticism went even deeper than just that one story, right? There was a broader critique of the tech itself.
Much dipper. A prominent tech vlogger named Mo Batar articulated a very compelling argument that we can call the prompts in a trench coat critique.
Prompts in a trench coat. I love that. What was his angle?
Batar looked at the repository and essentially said, the emperor has no clothes. These aren't groundbreaking new algorithms. They haven't invented anything new. These are literally just text files, markdown files, containing plain English instructions for Anthropic's language model.
His argument was that developers have been writing custom prompts for themselves for years, and the only reason Gstack got 50,000 stars is the halo effect of Gary Tan's elite status as the CEO of Y Combinator.
Yes, it's the accusation that hype and elite branding are masquerading as a technical breakthrough, that people are bowing down to text files.
I understand the cynicism, I really do, but I think calling it just text files is deeply uncharitable.
How so?
Think about aviation. A commercial pilot's pre-flight checklist is literally just a piece of laminated paper with text on it. But that just text prevents multi-million-dollar aircraft from falling out of the sky because it enforces rigor. It forces a process. If Gstack's text files prevent an AI from entering an infinite loop of hallucinated broken code by forcing it to stop and plan, isn't that packaging incredibly valuable? The value isn't in the code's complexity. It's in the discipline it enforces.
That is exactly the strongest defense of the tool. It's organizational technology, not just raw compute. However, the critics brought up a third danger that is much harder to wave away: cargo culting.
Cargo culting.
Yeah.
That is such a fascinating psychological phenomenon. Where does that term even come from historically?
The term originated right after World War II. During the war, the U.S. military set up these massive temporary bases on remote Pacific islands, bringing in huge amounts of cargo, food, and supplies via airplanes. When the war ended, the military packed up and abandoned the bases. The indigenous populations who had benefited from the cargo drops started building mock airstrips out of wood and lighting signal fires, mimicking the behavior of the soldiers, hoping the airplanes would return with more cargo.
Wow.
They copied the form of the behavior without understanding the underlying mechanism of supply chains and aeronautics.
And how does that apply to software engineering and Gstack?
In programming, cargo culting happens when a developer copies and pastes a block of code or adopts a highly complex workflow without having any idea why it works or what specific problem it solves. They just know Gary Tan says to do this.
So they blindly follow the ritual.
Exactly. The danger with Gstack is that junior developers will download this billionaire VC's highly opinionated workflow and start blindly relying on it as a crutch.
I see the trap. The AI runs the planning review command and spits out this beautiful, highly formatted markdown document detailing a complex database architecture. A junior developer looks at it, sees it looks super professional, and just rubber stamps it, assuming the AI possesses genuine senior-level judgment.
Exactly. They lack the hard-earned, painful experience to know when the AI is confidently hallucinating a terrible architectural decision. It amplifies overconfidence while completely hollowing out actual skill development. You aren't learning how to architect systems, you're just learning how to click approve.
So we have a tool that is undeniably powerful, capable of moving at breakneck speed, but it's fraught with hype and very legitimate risks to junior developers. Let's move past the philosophical debate and look at the actual telemetry. Who is Gstack genuinely for, and what are the actual metrics of success on the ground?
An independent analysis by Junior AI breaks down the target demographics quite clearly. The primary beneficiaries, the people seeing massive gains, are solo founders and incredibly lean teams trying to build complex applications quickly.
The people trying to punch above their weight class.
Exactly. It allows a single human to act almost exclusively as a project manager while the AI does the heavy lifting of the actual execution. It is also proving highly valuable for tech leads who are trying to wrangle chaos on small teams.
In what way?
Well, if you have 5 developers writing completely different random prompts to an AI and getting wildly inconsistent results, Gstack standardizes that interaction layer across the whole team. Everyone uses the same checklist.
And on the flip side, who should absolutely avoid this?
Highly regulated environments. If you are building software for a major bank, a healthcare provider, or an aerospace company where strict compliance, rigorous audits, and rigid playbooks are legally mandated, injecting an AI workflow that relies on probabilistic text generation is a massive compliance risk.
Right, you can't have an LLM casually rewriting your compliance checks.
No. It is also largely redundant for massive enterprise teams like Netflix or Uber, who already have highly mature, bespoke CI/CD pipelines that completely dwarf what Gstack offers.
The Gstack repository actually includes a fascinating file called ethos.md, which publishes the developer's internal efficiency metrics. And the numbers tell a very specific, somewhat surprising story about what AI is actually good at today.
The data is incredibly revealing. According to their internal tracking, when using the Gstack workflow, the speed of generating sample code and boilerplate improved by a staggering factor of 100.
100 times faster.
Yes. Writing unit tests and integration tests saw a 50-fold improvement in efficiency.
So you basically just watch the terminal light up and the syntax pours out effortlessly. But there's a massive drop-off in the next metric they reported.
Yes. When it came to complex architectural design, the efficiency improvement dropped to a mere 5x.
Wait, from 100x down to 5x. Why is there such a massive cliff between writing code and designing architecture?
Because they require fundamentally different types of intelligence. An LLM is, at its core, a probabilistic text engine. It excels at execution within a tightly defined, narrow context. If you give it a clear parameter, say, write a React button that turns blue when hovered, it will execute perfectly and instantly.
Because it's seen a million blue buttons in its training data.
Right. But architecture requires holistic systems thinking. It requires anticipating how a database choice you make today will affect server latency 3 years from now when user growth spikes. It requires understanding human business logic, budgets, and trade-offs.
It's a macro problem, not a micro problem.
Exactly. The AI cannot hold that macro context intuitively. It still requires heavy, deliberate human guidance to shape the box before the AI can fill the box.
It's an incredible typist, but a deeply mediocre architect. That is a crucial limitation for users to understand. But, the developer community didn't just use this tool for coding. My absolute favorite part of the source material is the discovery made on the Y Combinator subreddit. They found a way to use Gstack that has almost nothing to do with writing software.
Oh, this is a classic example of emergent user behavior. Among the core skills in Gstack is a command called office hours. To the general public, this just sounds like a generic brainstorming prompt.
Like, let's chat about my idea.
Right. But Y Combinator alumni looked at the structure of this command and immediately recognized what Gary Tan had done. Office hours is secretly a Y Combinator application pressure tester.
For anyone outside the Silicon Valley startup bubble, getting accepted into Y Combinator is statistically harder than getting into Harvard. It is a grueling, intimidating process. What the Reddit community realized is that this prompt forces the AI to interrogate your startup idea with the exact same ruthless, zero-fluff methodology that YC partners use during their live interviews.
It strips away all the marketing jargon and forces the user to answer 4 incredibly precise, brutal questions. Let's walk through the gauntlet because it's fascinating.
Let's do it.
Question 1. Do you have real demand or just interest?
That distinction is everything, isn't it? Because a lot of founders will say, I told 10 people about my app and they all said it sounds so cool. There's just interest, people being polite. Demand is, I told 10 people about my app and 3 of them literally gave me their credit card numbers today. The AI forces you to prove actual demand.
Exactly. Stop pitching and show the traction. Question 2. Name a specific human with the problem, not a demographic.
You cannot say, we are targeting millennial dog owners in urban areas.
The AI demands an actual name. My friend Sarah, who lives in Chicago, spends 3 hours every Sunday manually calculating this data. If you cannot name a specific, singular human suffering from the problem, you do not have a real market yet.
Question 3 is my favorite. What are people doing today without your product? What is the existing workaround? Because if a founder proudly says, oh, there are no competitors, nobody is doing anything like this, that isn't a good thing.
Not at all.
It usually means the problem isn't painful enough for anyone to have tried solving it. The AI wants to hear, Sarah is currently using a horrific, duct-taped mess of 7 different Excel spreadsheets just to survive. That proves the pain is real.
And finally, question 4. What is the absolute narrowest version of this product that someone would pay for right now? The AI essentially forces you to throw away your grandiose 5-year roadmap with blockchain integration and machine learning.
What is the ugliest, smallest tool you could build this weekend that solves Sarah's Excel spreadsheet problem?
Exactly. The genius here is that most founders spend weeks agonizing over the pros of their YC application, trying to sound smart. This tool attacks the foundational logic underneath the pros.
One user on Reddit pointed out that Gary Tan essentially open-sourced a 10% slice of his own venture capital brain. You can sit in your bedroom and have the CEO of Y Combinator's virtual clone grill you on your business model before you ever submit an application.
And this specific use case highlights a massive, broader shift happening in the tech industry right now. Analysts are starting to realize that in the current landscape, process packaging is beating model quality.
Let's expand on that. What does that mean for the AI arms race between these trillion-dollar companies?
For the last 2 years, the entire industry has been obsessed with raw model intelligence. Is Claude 3.5 smarter than GPT-4? Does Gemini have better reasoning skills? What Gstack proves is that the raw IQ of the base model is becoming less important than the constraints you build around it.
The bumpers on the bowling alley.
Yes. A slightly less intelligent language model wrapped in a highly rigorous, expertly designed workflow will consistently outperform a genius-level model that is just given a blank chat box and no instructions. It's no longer just about how smart the AI is, it's about how tightly you hold its leash.
Okay, so we've covered the history, the political controversy, the psychology, and the grand strategy. Now it's time to get our hands dirty. For the listener who wants to actually experience this cyberpsychosis today, let's walk through the practical installation and usage. What are the prerequisites?
If you want to install this locally, you don't need a massive enterprise server. First, you need an API key from Anthropic because Gstack routes its requests through Claude's infrastructure.
Okay, straightforward.
Second, you need to have Anthropic's Claude Code command line tool installed on your machine. You need Git for version control. And crucially, you need Bun version 1.0 or higher. Fortunately, it is supported across both macOS and Linux and runs on both standard x64 chips and the newer ARM64 Apple Silicon chips.
So I have my Mac, I have my API key, and I have Bun installed. What is the very next move?
It's a standard cloning process. You pull the repository from GitHub. You have a choice here. You can clone it into your home directory under .claude skills Gstack if you want these commands available globally across every single project on your computer. Or, alternatively, if you only want it for one specific application you're testing, you can clone it locally inside that project's .claude skills folder. Once cloned, you just execute the .setup file.
But the setup script is not the end of the process, is it? In fact, if you stop there, the entire tool is essentially useless. There is one specific file that dictates the success or failure of the entire stack.
Yes, the CLRUDE.md file. This is the central nervous system of Gstack's contextual awareness.
How does it work?
When you launch a Claude Code session in your terminal, the very first thing the agent does, silently in the background, is scan your root directory for a file named CLRUDE.md. If it exists, the AI reads the entire document to upload your project's context into its working memory before you even type a single command.
So what exactly needs to go into that file for it to work properly?
Everything the AI needs to know to not act like an idiot. You must explicitly define what the product is. Who is the target user? What is the specific technology stack? Like you have to write, we are using React, Tailwind CSS, and a Node backend.
You have to spell it out.
Completely. What are the strict coding conventions it must follow? What are your current sprint priorities? If you leave CLRUDE.md blank, the AI falls back on generic internet training data and will just give you boilerplate garbage. The tool is entirely dependent on the quality of the context you provide. It is a living document.
To really solidify how this feels in practice, let's walk through the real-world YouTube demo that was highlighted in the sources. A developer wanted to build a relatively simple feature for a React application. A UI component where a user pastes in a link to a Twitter post and the app generates a downloadable image screenshot of that tweet.
The developer starts the session and fires off Plancio review, typing in the basic request. Instantly, the AI reads the CLRUDE.md file to understand the React environment, assumes the CEO persona, and replies.
And it doesn't just agree, right?
No, it doesn't just agree. It expands the scope strategically. It says, if our goal is user engagement with these screenshots, we must ensure the component handles both light mode and dark mode natively. Furthermore, we should add a feature allowing the user to customize the background gradient behind the tweet before they download it.
It acts as a thought partner, elevating the basic feature into something much more polished. The developer approves the expanded scope and skips straight to the ship command.
And then the AI takes over the keyboard. It writes the React components, integrates the necessary styling libraries to handle those gradients, ensures the code complies with the rules in Claude IE-AMD, automatically commits the changes to a new Git branch, and opens a pull request.
So the code exists, but does it actually work? This is where the magic happens. The developer types Kuro.
The persistent headless browser daemon springs to life. The AI spins up the local development server in the background. It commands the invisible Chromium browser to navigate to the newly created screenshot URL on localhost. The AI virtually types a mock Twitter URL into the input field and simulates a mouse click on the generate button.
And what happens?
The application breaks. The terminal throws a 500 internal server error.
Let's break that down. A 500 error basically means the server panicked and gave up, right? What caused it?
By analyzing the network traffic and the terminal logs simultaneously, the AI diagnoses the issue itself. The mock Twitter API was returning data in a specific JSON format, but the AI's newly written React code was expecting a slightly different nested structure.
So a mismatch.
Yeah. When the code tried to parse the JSON data to find the tweet's text, it hit a null value and crashed the app.
So the AI broke its own code. But normally, a human developer would have to read the stack trace, find the correct file, change the parser logic, save it, and restart the browser. What does the AI do?
Because it is an agentic system, it course corrects autonomously. It sees the parse error, opens the specific React file, rewrites the JSON handling logic to correctly map the data structure, saves the file, and instructs the persistent browser to click the generate button again.
Without the human doing anything.
Nothing. This time, the screenshot renders perfectly with the background gradient. The AI verifies the visual output, pushes the bug fix to the Git branch, and finally outputs a success message to the developer. All of this happens in a continuous rapid loop without the human ever touching the code.
It writes, tests, breaks, debugs, and ships. It's astonishing. And the developer community is already looking for ways to break Gstack out of just the terminal. We saw discussions about integrating extensions like MindStudio.
Yes. The fundamental limitation of Gstack and Claude Code right now is that they are confined to your local machine's terminal. They cannot easily interact with external third-party services. But developers are building bridges using SDKs like MindStudio's agent skills.
By giving the AI access to external APIs.
Exactly. Imagine running your call command. The AI tests the app, finds a bug, and fixes it. But with an external SDK integrated, you could add a step where the AI automatically runs agent.send email, drafting a human-readable summary of the bug it just fixed, and emailing it to the QA team.
Or fetching real-world data.
Right. During the planned CO review phase, the AI could execute agent.search Google to pull live competitor pricing data directly from the web to inform its strategic advice. It gives the local AI a corporate credit card and an internet connection.
It completely bridges the gap between coding in a silo and actually operating a live business. Well, we have covered an immense amount of territory today. Let's pull all these threads together.
We examine the origins of the tool, tracing it back to Gary Tan's unique trajectory from a cold-calling teenage programmer to Palantir's 10th employee, and ultimately to the CEO of Y Combinator. We saw how his venture capitalist obsession with eliminating failure points directly informed Gstack's opinionated, heavily structured architecture.
We looked under the hood at the technical brilliance of the persistent headless Chromium browser, and how leveraging Bun's native SQLite access to literally steal cookies from Chrome eliminates the friction of automated testing. We debated the controversy, weighing the God mode hype against the very real dangers of junior developers' cargo, culting their way into massive architectural disasters. And finally, we walked through the tangible reality of using it to rapidly prototype and debug applications. But underneath all the technical specifications and the Twitter drama, there is a fundamental philosophical shift happening here. And that shift is captured perfectly in a quote Gary Tan made that kind of got buried in the noise. He stated quite simply that Markdown is the new code.
Markdown being the plaintext formatting language used to write basic documents and instructions.
Yes. Think about the gravity of that statement for a second. For the last 40 years, the most valuable skill in the entire technology sector was the ability to translate human logic into complex syntax C, Jack, Java, Python. If the technical barrier to execution is completely removed by tools like Gstack, if the AI can write the React components and debug the JSON parsers 100 times faster than you ever can, what is the role of the software engineer in 5 years?
It implies a total inversion of value. If the how of building software becomes a fully commoditized automated process, then the entirety of the value shifts to the what.
Exactly. The new secret sauce isn't your ability to write a flawless loop. It's your ability to clearly, precisely document your business logic, your constraints, and your desired user outcomes in plain English inside a Claude E.md file. We are moving from a world of builders to a world of directors.
The engineers who thrive in this new paradigm won't be the fastest typists. They will be the clearest thinkers. They will be the ones who can anticipate systemic failure, understand market demand, and orchestrate these AI agents with precision.
It is a fascinating, awe-inspiring, and honestly slightly terrifying transition to witness. Next time you open your terminal, ask yourself if you are acting as a typist, or if you are ready to act as a director. Thank you for joining us on this deep dive into Gstack. If you want to experience cyberpsychosis firsthand, pull down the repository, spend real time crafting your Claude MD file, and see what the machine can build for you.
And please try to get more than 4 hours of sleep while you do it.
We'll see you on the next deep dive.